Good morning everyone. I am G Madhuri working as Associate Professor at PSCMR College of Engineering and Technology. Today I am going to discuss about the topic CMOS inverter. CMOS stands for Complementary Metal Oxide Field Effective Transistor and inverter is a digital logic gate whose output is complement of the input. So today we are going to design the inverter circuit using the CMOS transistor. What is CMOS transistor? CMOS transistor is complementary metal oxide semiconductor transistor, which is a combination of N-channel MOSFET and P-channel MOSFET. MOSFET stands for metal oxide semiconductor field effective transistor. The metal that we are going to use here in the transistor is polysilicon, and the oxide is the silicon dioxide layer SiO2, and then the semiconductor. Here the semiconductor is N-type, the transistor is N-channel MOSFET. If the semiconductor is P-type, the transistor that you are going to use is P-channel MOSFET. And along with these three terminals, you have one more terminal, that is what the substrate, or it is also called as a bulk, or it is also called as the body. Now, if we come for this CMOS inverter circuit diagram, you can see this is what the logic diagram or circuit diagram of the CMOS inverter. If you look here for the CMOS inverter consists of one input and one output. And here you are going to make use of one PMOS transistor and one NMOS transistor. Looking after the connections, the input is connected to gate of the PMOS transistor as well as the gate of the NMOS transistor. And output is collected across the drains of the PMOS transistor and drain of the NMOS transistor. If you look at the supply, the VDD is connected to the source of the p-type transistor and the ground is connected to the source of the n-type transistor. So this is the circuit connection of the CMOS inverter. If we go for looking after the operation, as I told you, when you apply the logic 0 at the input, you are going to get the complement of the complement at the output. So when a logic 0 is applied across the input, a logic 1 is obtained across the output. And if we apply a logic 1 at the input, the output will be a logic 0. So, if we represent that, so when a logic 0 is applied, what happens? See, here the n-type transistor is completely off and the p-type transistor is completely on. So, this p-type transistor will be operated in the resistive region, hence you have represented that with a resistor, and the n-type transistor is completely off and it is represented as an open switch. So you can see that the output is here connected to VDD. So when Vn is equal to 0, VDD output is equal to VDD. And when Vn is equal to VDD, then the n-type transistor is completely on and it will be in resistive region, and p-type transistor will be completely off. It acts as an open switch. So you can see the second diagram. Here the n-type transistor is on and it is operating in the resistive region, hence it is represented with the resistance. And if you look at the p-type transistor, the p-type transistor is completely off, hence it is represented with the open switch. So the output now discharges through the resistance, hence you will get an output of logic 0. So the output will be a 0. When Vin is equal to 0, you are going to get the output Vout equal to VDD, and when Vin equal to VDD, the output is going to be 0. So in this way, in the steady state, this is what the steady state response of the CMOS inverter. The CMOS inverter acts as a NOT gate, which is nothing but the output is complement of the input. Thank you.